Hello, and welcome to another episode of the Deep Learning with PolyAI podcast. I'm your host, Damien, and I am here with PolyAI's senior machine learning engineer, Tomasz Kich. Did I say it right? I messed it up already, didn't I?
It's all right. All right. It's cheaper, but it's all right.
All right. We're good. Straight from the horse's mouth there. Tomas, thanks so much for joining us today. We have a very special, very timely episode of the podcast because we are here to discuss what Tomas is picking up along with some other members of PolyAI's engineering team at arguably the World Cup, maybe, of AI conferences, which is NVIDIA's GTC. It's happening right now. It's live. By the time that this podcast goes to air, it'll be the final day of the conference. And so we are going to give a recap as to what Tomas has seen so far, some standout sessions, a little bit about what we presented at because we are a premier AI player. And so, of course, we're going to be presenting at NVIDIA, but also any sort of general buzz speculations from other attendees, from other presenters, and just some nuggets that we pulled from the first few days of NVIDIA's GTC. So, Tomas, welcome to the podcast.
Yeah. Thank you very much, Damien, for having me.
Of course, of course. Great. So, first things first, you've been there for a couple of days, you've watched a lot of sessions, you have presented so far, but let's talk about what are some of the key, maybe the two or three standout either sessions or topics that you thought were really sort of incredibly intriguing, fascinating, very well attended, or otherwise like maybe even controversial. What are some of the ones that have stood out so far?
Yeah. So, like the first thing you will notice, there's over 1,000 sessions happening during the event,
Yeah.
and most of them are about LLMs or generative AI. And we were one of the few companies to present about something different, which is ASI. Um, yeah. There's also a lot of talk happening about scaling the current infrastructures or the HPC coding right now, but also a few very jaw-dropping presentations where the keynote is always presented by Jensen when
Okay.
they announced the NVIDIA Blackwater platform, which is allegedly supposed to reduce the cost and energy requirements of high-performance AI systems by 25x, which is a huge deal for a variety of reasons. One being mainly cost and environmental impact, but also just like physical constraints of the server rooms. Because if you can fit 25x in one system, that like we have 25 more of them coming up in the same server room. Um,
Now, is this? I mean, is it because I remember for OpenAI's conference that one of the key takeaways was the reduction in cost as they moved to GPT 4.5 and Turbo. Um, how impactful is this in comparison to something like that for ultimate end users? Whether it's it's a vendor like PolyAI, or whether it's an end user who's going directly to NVIDIA for their own internal builds. What is this? Is this more impactful than that announcement? Less based on scale, based on utilization?
so it is a very impactful announcement because it's a very grassroots improvement to an actual hardware that we are working on. So like basically right now, every company almost wants to build their own AI or they are experimenting with AI. So they
Sure.
need to use the hardware, and that will most likely be a hardware from NVIDIA. So even that can reduce the cost of any like AI experiments by 25x. And that will also trickle down to AI customers because most of the companies are using the NVIDIA hardware as well. So
Yeah.
the cost reductions will also probably be noticeable by the end customers of these solutions.
So from a cost perspective, more compelling to do some internal experimentation, but of course, this does nothing to mitigate those other fears like risks, threats to infrastructure, demonstration of value, et cetera.
Yes, exactly.
Yeah, that makes a lot of sense. What else was in the keynote that was of particular note?
So yeah, one thing is that was very loud about on Reddit was the speculation of actually how big the ChatGPT 4.0 is. And we are getting some models that are actually getting into trillions of parameters of size. And
Oh,
that's
wow.
another reason why this 25x cost reduction is becoming very important right now, because training at such scale is extremely costly. And at this point, we also have to consider the environmental impact of all of that. So 25x reduction in energy requirements is also something that should not be brushed aside.
No, from an ecological perspective, that makes a ton of sense. And of course, that is a huge concern. The resource consumption, not just in capital, but like you said, carbon impact. So, was that also a prevalent term in some of the side conversations? I know you said they were dominated by LLM talks, but were people taking a look at responsible and ethical utilization of AI from a hardware and infrastructural standpoint?
I have attended one very interesting talk about building simulation engines, and they were basically talking about building a energy infrastructure that would scale across multiple European countries because the energy requirements to train these systems and maintain the systems are no longer something that a single country can manage.
Right.
So they are basically proposing an architecture that would span like a few like European nations, and they would all provide their own electricity supply, so that we can have these weather predictions. They're very, but yeah. So the reason is like weather predictions, we all benefit from them, and the hardware and like the software for them is becoming very expensive, and so multiple countries should contribute to the energy requirements of that.
That's incredible. Was there any speculation that this would serve as like a foundational model for the rest of the world to catch up with? Or is this something that's already in place in other parts of the globe?
So it is something they are actively trying to propose, but also these systems are not necessarily AI based right now. They are
Sure.
experimenting with generative AI forecasting, but they are also using a lot of um, traditional AI systems and just traditional forecasting systems. And the cost comes into play when we're talking about the resolution of the forecasting, because maybe we just want to know what's the weather like, in the area of like 25 kilometers. But what if you want
Sure.
your resolution to be like 5 kilometers or maybe 1 kilometer? It gets exponentially, uh, more difficult and cost demanding.
Because right now that's sort of relegated to Doppler systems and archaic infrastructures, right?
Yeah, exactly.
Yeah. That's incredible. With regards to the shared model, did it have any tie into it? And if not, maybe this is completely off base, but just with regards to other regulatory motions, in the States, we like to call them riders on bills, right? Stuff that has some loose correlation to the fundamentals of a new piece of legislation or legislating for, let's say in this case, a new technology. Obviously, with the EU Act, or the EU AI Act, there's some like foothold with regards to getting a, a co-opted adoption of regulatory requirements. This is very use case specific, but was it tied to any sort of reference on larger general AI regulations?
So during this call, this talk, they mainly focused on the actual problem and the solution, not necessarily about the legal constraints. But there were mentions about where this infrastructure should be put, because they suggested putting it in Europe and, like, for example, Norway and other countries, and not
Mhm.
necessarily in like Gaza region because of political problems. And that's
Sure.
also something very important to keep in mind, because this system would be extremely expensive to create and maintain.
So is okay. So the consensus needs to come from an infrastructural standpoint on developing and the costs and the resources necessary for that sort of thing. But also, we're looking at a geopolitical climate that's almost constantly in tumult. And so, in
Yeah.
order to get something like that, all right, that makes a ton of sense. Um, all right. So, going to maybe a lighter topic, what else have you seen for maybe some other sessions that have really stood out, aside from the keynote declarations, aside from the 25x cost reduction? What else have you seen that really sort of stood out so far?
Yeah, one very interesting discussion we are observing right now is that there's a lot of talk about making the models bigger, or making the context in your LLM larger, or maybe creating a bigger data set. But there was also a brilliant talk by Sebastian Bubek from Microsoft, talking about how this is not necessarily the correct way to go. In his presentation, he basically showed us a research experiment that he and his team did. They took a very small model, and they were basically curating the data set for the majority of the runtime of the experiment. So they published a paper titled textbooks is all you need. They claim that basically textbook level quality data is way more important for your model than actual size.
Okay.
Because like when you look at models like GPT-4, it is trained on huge amounts of data.
Right.
And most of this data is of quite poor quality because it is just internet scraped. So if you want your model to be able to write a good science fiction novel, if it's trained on one or two great science fiction novels and thousands of bad ones, chances are the response from the model will also be a bad science fiction model.
Yeah, makes sense.
Yeah. So the experiments the team was conducting is basically what happens if you only give it good science fiction novels.
But of course, I mean, from an endpoint, or from an end user standpoint, I think that's what anyone who utilizes those LLMs will see. What we'll call maybe the ultimate creativity behind the output is the induction, inflection. No, is the imbuing, is the training on such a large data lake that at the end of the day, that's what makes it sound creative and realistic, almost in the way that the prompts are engaged and responded to. So you take out all the bad novels, and yeah, you get a higher quality output, but you also get something that sounds a lot like, like the Philip K. Dicks of the world, as opposed to everybody else who's just talking and having conversation. But I do understand the nature and the attraction of a smaller language model. I would say originally, from a cost standpoint, easier to manage. Now, though, with the LLM sort of like slashing costs with new models that come out, is small still cool?
Yeah, that's a perfect question because like to address your first point between only training on good data versus training on all data, it
Yes.
also very much depends on your use case because sometimes you need a model to only process good responses, and that will be use cases such as medical, for example. You cannot
Right.
train a medical model on Reddit and just see what happens.
Well, you could, but I would not want. I would not want to trust that model.
Yeah, exactly. Exactly. Um, but yeah, it's another huge benefit of having a small model that is the inference time. Because when you have a huge model, like one of the obvious costs is that you have to train and you have to host it somewhere. But another issue is that actually users want quick responses.
Okay.
The smaller your model is, the faster you can get the responses out. And also the cost of actually having it running is also reduced drastically.
Isn't that the sell points though for like current iterations of LLMs is heavily reduced latency, even though their models are massive?
Yeah, yeah. Like we are constantly observing improvements in latency, and that is due to like very smart programming. There's due to the development of new CUDA kernels and like very low level programming on the GPUs, and also as mentioned in the keynote, the new hardware architectures as well. But yeah, like with the scale, like for example, a company might want to have a bunch of models running. That's also it's becoming problematic when all of them are huge.
Yeah, I guess
Um,
that's true.
Yeah, and another problem mentioned in that presentation about the size of the models is that there's a lot of discussion about like emergence of new capabilities in these models when they increase in size. And yeah, Sebastian does not necessarily agree with the sentiment. He does not think it is fair to say that algebra emerges at 8 billion parameters, for example, because he also claims that it is all due to the data and we should not just look at the size of the data set and see what happens when we make a model bigger or smaller. Data set is also a component we should be tuning in order to achieve a model that we actually want to achieve.
Sort of a garbage in, garbage out thought
Yeah,
process, huh?
exactly.
All right. Yeah. I mean, and that makes sense, right? It's not just that, and that's not specific to the realm of AI or the realm of data powered AI. It's just everywhere else. Like it's not the size that matters. It's the application. It's the use case. And sometimes that pre fine tuning, as you could say, if you want to put a marketing spin on it, is probably more compelling depending on the use case. I mean, after all, like PolyAI got started on a proprietary language model that was built specifically for conversational AI and specifically for the voice channel because it wanted to, sort of come across as being as conversational as possible while also reducing that latency. Um, and so the fine tuning sort of started before the deployments. Cool. All right. What else? What else have you seen? What else have you seen that sort of stood out aside from Microsoft's declaration that bigger isn't always better? Coming from
Um,
Microsoft, by the way, that's just hilarious.
yeah, exactly. So another interesting talk that I watched and a few other members from the technical team worked was a basically discussion between industry leaders about how to actually deal with the LLMs. Because there is a lot of problems with them. They do hallucinate. There's a lot of latency problems. That it is a very complicated problem how to actually control them, be polite. So yeah, from what we observe, we are not the only ones struggling with that. It is in a way reassuring to see that, for example, people from Microsoft or NVIDIA also having the same problems. And
Right.
what we observe from this conversation that we are approaching these problems in very similar way they are doing too. So yeah, there's a lot of very good research sharing right now in the community. Everyone is trying to figure out how to make these models actually work and be valid for production. Looks like maybe everyone is converging to the same set of ideas. Whether or not these ideas are correct, only the time will tell. But yeah, we
Okay.
have a lot of great minds working on this problem right now.
Yeah, I mean, it's that constant struggle. And again, this boils down to what's the application, right? Because it's all about control. When you yield control, you get more creativity, you get more, spontaneity, you get quicker deployments, et cetera. But there's more risk. Things like, on the innocuous standpoint, a hallucination. On a more severe standpoint, like in medical applications, you get damaging, if not harmful advice. So I'm glad to hear that we're keeping up with the big dogs, as they say, with regards to our approach to limiting those sort of uh, uh, less than ideal outcomes. What now? You mentioned that everyone else was talking about LLMs. What did we present
Yeah, so we did not present about LLMs, and that is
on?
okay. Yeah, we presented about ASR. Because for us, ASR is the
That's
first point of
automatic speech
contact.
recognition for
Yes,
for
exactly.
you folks who are not hip to all the acronyms. A key component in spoken language understanding.
Yeah, it is a first point of contact when we receive a phone call. Everything goes through our ASR system, and then it goes to the rest of our basically pipelines. So ASR goes badly, the errors trickle down to everything else. Part of the design is to be able to recover from these errors, but also we want to make sure these errors are minimal. So in our presentation, we mention how popular pre-training data sets, like for example, Libri speech, are very different from what we observe in real life. So like the key differences are all these data sets, most of them are read by a voice actor in a studio, while the phone calls we get are just people having conversations. It might be noisy, it might be unstructured. Uh, and yeah, all your data sets also have, there are basically no noise in them unless the noise is the point of the data set.
Right.
So yeah, even like these simple differences make it so that after we train the model, like we already take a very good model, does very well on Libri speech and other like popular data sets, and we fine tune it on our data, we observe huge benefits from that just because there's so much noise and there's so much like latent differences to how our customers speak compared to the popular data sets. That is, it's basically necessary in a way for us to do these steps. Less, as also I showed in the presentation, if you don't do that, or if you choose out of the box model from a third party provider, that is might not necessarily be critical for your use case. The results can be pretty bad. Like
Yeah.
certain models we tested got us an approximately 50% word error rate, which would mean half of the words were incorrect if you just choose a wrong model from a third party provider.
which is
and
bad
you
on its
cannot
own,
diagnose.
but then you put it, which is bad on its own, but then you put it in like a model or a tech stack that relies on like multiple intent identification, and you just get something that's a disaster.
Yeah, exactly.
Wow, that's pretty intense. What? No, we won't name those models. We won't name and shame today, but they're out there, folks. So just be wary. Obviously, speech recognition is massive for us. It's also why, as a voice first company, it's one of those things that we need to make sure that we get right, because a lot of other companies that just kind of take a text to speech model and then slap a automated voice on it, they don't focus the number of resources into this level of understanding on the recognition standpoint. Like you said, it's the first point of contact. So getting that right is essential. How was it received?
Yeah, so the reception was very positive. I got also a lot of good feedback on LinkedIn after the session. So yeah, I'm quite happy to say that yeah, it was useful and people did like it. Also, in our session, I mentioned our preference towards smaller models, at least in the ASR space. So that is kind of in line with what Microsoft was talking about, because
Nice.
there are some huge ASR models out there, and we tested them, we played with them, but for now we use quite small models, and we are perfectly happy with them. So yeah, that's something important to keep in mind. I think that's a very big takeaway, because like not everyone, even like for like inception startups or individual contributors, not everyone has resources to play with huge models. And
Yeah,
turns out you don't really need these resources. You can make perfectly good things with smaller models.
absolutely. And I'm going to or I'm going to place a stake in the ground and say, we did not follow Microsoft's lead. Microsoft
No,
followed our lead.
exactly.
Amazing. Well, I know you're in the thick of it right now with regards to the other sessions that are going on and the thousands that are kind of happening at once. Is our session that's been presented, is it already available to stream? Now keep in mind this episode will probably go live on Thursday, the 21st of March. So is our session available to be viewed right now?
Yeah. The session is available. Most of the sessions are available 72 hours after they were streamed live. So you can probably find the link in the description.
Excellent. Excellent. Amazing. Well, we'll be sure to check that out, Tomas. I really appreciate any other big nuggets or any other little murmurs, even around the crowd, for merger and acquisition activity in the space, or anything else that was causing a buzz.
We are seeing at the keynote a lot of big logos slapped very close to the NVIDIA logo. There is
All
something
right.
happening.
All right.
There
There's
is
something
something
happening.
happening.
Stay tuned. This is a big, it's almost like a kaiju battle that's going to go on here. So that's incredible. Well, I really appreciate the feedback. Thanks for being the feet on the street reporter, and thanks for presenting and representing PolyAI at what is arguably the World Cup of AI conferences at NVIDIA and GTC in 2024. Tomasz, it was a pleasure to have you on the podcast. We hope to talk to you again real soon. And for everybody else,
Yeah,
we'll see you next week.
thank you.